Welcome back. Today we're going to solve absolute value inequalities. This one we're going to specifically do the less than or less than equal to inequality. That's called your and compound, and it's also called a conjunction. Very similar to the equations that we solved with the last lesson, except now we have to deal with the inequality. So go ahead and grab your composition books and let's get ready to go. So I've got the first equation, if you could write that one down. I'll work through it with you. So just like with the equations, I want to get the absolute value piece alone. So anything outside of that on the left side we have to undo. So since there's a plus 5, I'm going to inverse that by subtracting. And I'm going to subtract 5 from both sides. Now, since this is a less than, it's an and compound, I'm going to set this up, just like that, like a compound inequality when I set up my 2. So I know this has to turn to a negative 2 at some point. So when we write our compound, that's actually in the lead. So it's negative 2 is less than, and then I'm going to pull out what's inside the bars, which is less than, and then the 2. So you still have your 2 inequalities. This is one of them. And then if you read this one from right to left, this is your other one. 3x minus 1 is greater than negative 2. So now I'm going to solve for x. So I'm going to add 1 all the way across on both sides. And then divide everything by 3. So there's my solution. Now we have to graph this. So we are going to solve and graph. Just like we did with the equations. So on your number line, I'm just going to capture a small part of it since those numbers are pretty close to each other. Just thinking how I want to break this up. I mean, you could put it into thirds if you wanted, but I'll just go by ones. So when I plot these, now there's going to be a range, so I know I'm going to have a negative 1/3 and a positive 1. But at those locations, since it's just a less than or a greater than, it's going to be an open circle. So it's what I call an open circle. I'm not going to close it because it's not including the 1. And then the same thing at negative 1/3, which would be just to the left of the 0. Now I have to decide shading-wise. X is going to be less than 1, but it's greater than negative 1/3. So it's going to end up being in between the negative 1/3 and the 1, just like that. So that's the nature of the compound. And the conjunctions is you kind of shade together on those types of inequalities. And that's when you have the less than or less than equal to begin with. All right, let's move on to the second example. Okay. So once again, we've got a less than, but it's a less than equal to. So we'll, notice at the end when we go to graph it, there's going to be a slight difference from the first one we did. So once again, I have to get the absolute value alone, so I'm going to add 3 to both sides. Now I'm going to put this into the compound inequality. So this will be a negative 2. I got another 2 is less than equal to x plus 2, which is less than equal to 2. So I took what was in the bars, that kind of goes in the middle, and then I set 1 less than equal to 2. That was the original one right here. And then just flip on the other side, it ends up being greater than equal to negative 2. So x plus 2 greater than equal to negative 2. There's your second one right there. So now I want to solve for x, so I'm going to subtract 2 all the way across. Okay, so there's my solution. It's bounded in between negative 4 and 0. So on my number line, okay, so now I go to graph it. Now the difference with the second one over what we did on the first one, since the first one just had less than symbols, they didn't have the little equal to bar, it was open. This one has less than equal to, so I'm going to close, it's kind of got a closed circle on the negative 4 and closed on the 0. And I want to shade in everything that's less than 0, so that would go this way. Everything that's greater than negative 4, so they would come together in the middle like that. And again, that's the nature of the conjunctions. Okay, let's do one more. Let me find it. Okay, so there's your inequality. Now this one, I don't have anything outside the bars on the left side, so I'm going to go ahead and set up my compound inequality because it is a less than, so it's a conjunction. So this one will look like, so I'm going to take the 2x minus 5, less than equal to 9. Okay, but then I'm going to flip it so this stays less than equal to, if you're reading it from left to right. And then this becomes negative 9. So really I kind of separate it. So like if I did this, you know, there's one of them. 2x minus 5 is greater than equal to negative 9. And then to cover this, and 2x minus 5 is less than equal to 9. So I ended up flipping, you know, this inequality has to flip when you make it negative. Okay, so now I want to solve for x, so I'm going to add 5 all the way across. And then divide by 2, everything. Okay, so on my graph, these are kind of spread apart. I'm going to go by 2s, I think. So if I make, I probably don't need it that long, but that's okay. So 2, 4. Okay, so I will plot negative 2. And now this one also is equal to, so this is going to be closed. And then 7 would be in between 6 and 8. So then I'm going to close that at 7. And it's everything less than 7 but greater than negative 2. So it's going to be in between.